math enthusiasts, welcome to your channel, the go-to destination for all things mathematics. I'm Ziba and today we are diving into the fascinating world of trigonometry. But before we dive deep into trigonometric C, let's briefly understand what trigonometry is all about. So, trigonometry is a branch of mathematics that deals with the relationship between the angles and sides of triangles. It's an essential tool in various fields like physics, engineering, computer science, and more. You might be wondering, why should I even care about trigonometry? Well, trigonometry isn't just about abstract angles and triangles. It's a powerhouse in solving real-world problems, from calculating distances and heights to understanding wave pattern and oscillation. Trigonometry is everywhere. Okay, so in this video, we'll start with the basic and work all our way up. And in this trigonometry series, we will cover a wide range of topics, including basic trigonometry function, unit circle, angle management, solving triangles, and more. And each video will break down complex concepts into easy to understand segments. And remember, guys, learning is a two-way street. Feel free to comment with any question or topics you'd like me to cover in future video. I'm here to help you on your math journey. Alright, buckle up because our trigonometry adventure is about to begin. Hit that subscribe button, ring the notification bell, and let's explore the angles of mathematics together. I'll see you in the video. So, as I just mentioned, trigonometry, right? The word should ring a bell. It is very similar to the word triangle, right? So, that's how the name has been derived, and it talks about the triangle, its properties, and then it expands on it. So as I just mentioned, let's start with triangles and see what are the properties. What are the important properties of triangles that you have to remember and use it in trigonometry? We start with right angle triangle. Okay, so let's call this CAB. So usually for sides we use capital letters, and for angles we use capital letters, and the sides we show it with small letters. Okay, so A, B, C. And as you know, the sum of the inside angles of a triangle must be equal to 180, right? A, B, C, right? Must be equal to 180 degrees. Okay, and then as you know here, C is 90 degree. Okay, so here A and B together must be equal to 90 degree. This is one important property, like of right angle triangle or any triangle you have to take advantage of when you're dealing with trigonometry questions. Another important thing is, in a right angle triangle, we can use the Pythagorean theorem. So what does it mean? This side, which is right in front of the right angle, is called hypotenuse, right? Hypotenuse. I show it with this one. Okay. So hypotenuse, which is C, small c, there is a relationship between hypotenuse and the other two sides. So each side to the power 2 added together, then square root equals to hypotenuse. Okay, this is how you can calculate the hypotenuse. And remember, this Pythagorean theorem only applies to right angle triangles. To give you an example, okay, so let's do an example to make it easier to understand. Okay, so I give you, let's say here, I'll do an example in blue. So this is a right angle triangle. Okay, so this is 3, this is 4, the unit is meter. Okay, and here, let's say this is 26 degree, and the question is asking for this one, this angle, and hypotenuse. What is the length of the hypotenuse? Okay, so let's start with the length of the hypotenuse. We are going to use the Pythagorean theorem. So h is this side to the power 2 plus the other side to the power 2, then a square root. So 9 plus 16 is 25. So your answer is plus and minus 5. But remember, guys, here there is a very important point to remember. The side actually is the magnitude, is the distance. And distance can never be negative. Okay, so although in mathematics, in terms of mathematics, you get your h, the hypotenuse, to be plus 5 and negative 5, but negative 5 is not acceptable. Okay, not acceptable. Why? Because distance, it's never distance is never negative. In other words, let's say, let me remind you of an everyday application. Let's say you are moving from your house to your college and you put your address in the GPS, and then it always gives you a positive value. Let's say it gives you 7 kilometers. It never tells you like negative 17 kilometers, right? Because distance is always a positive value. So here the hypotenuse is positive 5, and now we have to calculate this angle. Let me call this angle B, okay? So what I know, this is 90 degree, so this angle and this angle together should be 90 degree. In order to find angle B, that would be 90 minus 26, which is 64 degree. Okay, so using these two properties, you can use the missing side and the missing angle. These are the two most basic and very important properties of triangles. Now, stay with me with the rest of the video. We will talk about the most important basic function of trigonometry. Okay, guys, so the second part of this video, we will discuss about the most important functions, actually the first three basic functions of trigonometry, and how another three function will be derived from these three. Okay, so the most basic functions in trigonometry, we have sine, cosine, and tangent. Sine, cosine, and tangent. And we will define them using a, yes, right angle triangle. Okay, so, and I'm pretty sure most of you have heard about SOHCAHTOA rule, which is actually the acronyms. Let's talk about it, then you will see. So by definition, sine of an angle, okay, sine of an angle, it's the opposite side over hypotenuse, right? So remember, put it as a side note, whenever we're talking about a sine of an angle, when we are talking about the functions in trigonometry, we are talking about an angle, okay? So sine of an angle. The angles, they could be shown with small letters or capital letters, or some people prefer to use Greek letters like theta. So here theta is your angle, okay? And then if we want to define the sine of this angle, it would be the opposite side over hypotenuse. And this is the formula. So if you use the acronym sine S, opposite hypotenuse, SOH. Okay. Now, the second most important trigonometry function is cosine. Here again, if your angle is theta, the cosine by definition is adjacent over hypotenuse. So that would be CAH. So CAH. And let's see what is the third trigonometric function, tangent. Tangent by definition, it's sine over cosine, or in other words, opposite over adjacent, right? So tangent is OA, TOA. this is how you can define, okay, this is how you can define the basic trigonometric functions. You have, you first of all, you identify an angle, then you start finding these ratios. There is an important thing about the sine and cosine that I have to explain to you guys. The sine of an angle, the value, it's always between -1 and +1. The same thing applies to cosine of the angle. So +1 and -1. So negative, it's always the minimum, right? So the negative is always the minimum. The +1, it's the maximum. And later on, when we graph the sine and cosine, you will see that what is, like you will see on the graph, actually, you can visualize what is mean and maximum. Okay, guys, now let's remember, I told you like about the three basic functions. From these three, we can define another three secondary functions. So let's say sine, it's opposite over hypotenuse. I will define another function which is cosecant. Okay, cosecant uh, of an angle, it's 1 over sine of the same angle. If you have cosine, the reciprocal of it, 1 over cosine, it's called secant. And then if you have, if you reciprocate your tangent, 1 over tangent of an angle, it's equal to cotan of the same angle. So you have, in total, you would have 6 trigonometric functions, but 3 of them are the basic ones. This is how they are defined. So let's say, for example, secant, it's 1 over cosine by definition. So if you want to find secant, you could say it is hypotenuse over adjacent. Now, another important thing that we have to consider when talking about angles, we have to be able to measure them, right? Yeah, like distance. Let's say when we want to use distance, we use length measurement like millimeter, centimeter, mile, kilometer. These are all the different units we use. Here, when it comes to angle, there are two very important, actually, let's say unit of measurement that you have to learn, and you have to learn how to convert between these two. It's called degree and radian. So degree and radian. Let me write it down. Degree. And then here on this side, I will write radian. And I want to show you how to quickly convert between these two. Okay? This is very important. I never recommend you guys memorizing something. Try to learn the concept. When you learn the concept, you will remember how to use the different formulas. Okay, talking about the units of measurements of angle, remember I said we have two very important units, degree and radian. First of all, we have to see which each unit is by definition and how to convert between these two units. But before I start, I want to I want you to pay attention to something. Whenever I talk about degree, I write it in blue, and whenever I talk about radian, it would be in pink. But before we start, I have to show you something. So this is a circle, and this circle is divided into 4 equal parts, okay? And each part, it's called a quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so we have 4 quadrants in a circle. That means 4 equal parts. Okay, and then there is one more thing I want you to know. There is two direction of movement. You can either move in this direction or this direction. This is clockwise, this is anti-clockwise. So if you move this way, your angle would be negative, and if you move this way, your angle would be positive. I will elaborate on these like soon. You will see how to use them. Okay, and the third side note is for you guys to remember that when we're talking about angles, okay, so when we're talking about angles, we have two sides. Okay, let me show you something. Let's say this is an angle, okay? I have two sides attached in one point, and I have two arms or two sides. Okay, so the angle can be extended from this way or even from this way. Okay, so your angle once more has got two sides, right? Any of these sides can move. Okay, but when it comes to a unit circle, we have one specific definition. Let's say when the initial arm of the angle is in the positive x-axis, we call it in the standard position. So this is the initial arm of an angle. This is the other arm. Okay, so here in between, you will see that there is an angle. So this angle can move this side can move and make an angle. Can you see that? Right? Can you see that? So it can move, but as long as the initial arm is in the positive axis, we call it this angle is in a standard position. Okay, if it's not in a standard position, this initial arm could be anywhere. It could be here, or it could be, let's say, here. But when we're talking about the standard position, the initial arm must be on positive x, but the other arm, terminal arm, can be anywhere. Okay, so let's see how we can relate these two units and how we can show the different angles. Talking about a circle, as all of you know, a circle is how many degree? Yes, correct. So a circle is 360, and this is the symbol we use to show degree, right? So degrees are very familiar because we use it so often, and each degree it's further divided into 60 minutes and each minute into 60 seconds. And it's commonly used in everyday life, as I just mentioned before, particularly in geography, astronomy, and navigation. Okay, so remember, each circle, it's 360 degree. So that means if you start from here and you go all the way, one turn or one revolution of the circle, it's 360 degree. Okay, for the other units that I talked about, you radian, okay, so it's actually based, it's actually based on the radius of a circle. Okay, so each, let's say, circle in angle would be 2 pi. Okay, and here this is the radius, right? So how can we find the relationship between these two? Simple. Yes, we know that one, right? One circle is 360 degree, or in other words, it's 2 pi. So we can easily equate them and find the relationship. So I just write it in the relationship, I just write it in red. 360 degree, it's 2 pi. This is one of the most important formulas you have to remember. 360 degree, it's 2 pi. Or if you look at some textbooks, you will show these formulas as well. 180 degree, it's equal to 1 pi. Because both side has been divided by 2 to get this one. right? Or in other words, you can further divide it by 2 and get 90 degree is equal to pi divided by 2, or even further, 45 degree is pi divided by 4. Okay, so this is how you can convert between these two units. If the question asks you to do your calculation in one of these specific units of measurements, you have to do so, or you can still choose any of those. But remember, at the end, the final answer should be converted in the form requested by the question. Okay, before I finish this video, I want to just quickly go over another concept. So let's talk about angles. Okay, so let's say I will give you a few angles, 30 degree, and I want to show it which quadrant it lands into, and then how I can graph it. So let's say positive 30 degrees. So first of all, it's in degree. So it starts from here. So let's say if I want to show you in here, this is your circle. So it starts from here and then 30. So this is the initial arm, this is the terminal, and this is 30. And how do you know this? Because 30, like 1/4 of a circle is 90 degree, and 30 is 1/3 of it. And another point you have to remember, it's the sign. So it's a positive value, so your direction of movement is anti-clockwise. The other angle I want to show you is pi divided by 4. So again, here the angle is positive, so this is your direction of movement. And remember, guys, so 90 degree, okay, it's pi divided by 2. Pi divided by 4 would be almost here. Okay, so again, this would be your initial, this would be your terminal arm. For me personally, I always, when I come across a ratio in radians, I quickly change it into to degree, because for me it's easier to visualize it. Let's say if I'm given, let's say this one, so minus pi divided by 3. Okay, so I'm given this one. I might find it a little bit difficult to work it out through radian. First of all, what I'll do quickly on the side, I would say pi is equal to 180. So I divide it by 3, so that must be negative 60, okay, in degree, okay? So I start, if this is 0, you have to move this way because it's negative, and then 60. So if 1 pi is 90 degree, this would be 60, right? So this would be your initial, this would be your terminal, and this would be your angle. Okay, so this would be minus 60 degree, or in other words, minus pi divided by 3. I hope you enjoyed this video. Try to do lots of practice questions, learn the concepts. In the next video, we will be talking about the graphing of trigonometric functions, how to find the domain, range, and other stuff related to them, and how to solve questions, equations. See you in the next video.